Hello everyone, welcome to CodeChef. Myself Jwala Chaurasia, and today we are going to solve a problem which came into starters 213. The name of the problem is mean difference and the problem code is MEANDIFF. The difficulty rating of the problem is cakewalk/easy and the prerequisite is a doc. Let's start with reading the problem statement over here. So guys, problem says this is the easy version of the problem. The only difference between this and the hard version is that here you must find the answer for only the given array. For an array B of length m, we define the following. Average of B is the average of B rounded down formally like this, that is average of B, where this denotes the largest integer not exceeding x, also called the floor function. F of B is the maximum difference between an element of B and average of B. That is f of B is equal to max of where I is equal to 1 till m, where it consists absolute value of B of I minus average of B. So here denotes the absolute value of x. For example, this is the absolute value of x. That means when it's negative inside it, it is a positive value. So you are given an array A of length n, compute the maximum value of f of s across all non-empty subsequences of s of A. S is said to be subsequence of A if S can be obtained from A by deleting several, possibly zero, all elements. For example, like this. Input format, the first line of input will contain a single digit t denoting the number of test cases. Each test case consists of two lines of input. The first line of each test case contains the single integer n, denoting the length of the array A. The second line contains n space separated integers a1, a2 till a of n. Output format for each test case, output a new line, one integer, the maximum value of f of s for some subsequence of A. Constraint for t lies from 1 to 10 to the power 5, for n lies from 1 to 2 into 10 to the power 5. A of I lies from 1 to 10 to the power 9. The sum of n overall test cases won't exceed 2 into 10 to the power 5. Now let's understand the sample test case in the question more precisely over here. So guys, this question is pretty much straightforward. It says that and for an array B of length m, we define the following. That is, this is the average of B, okay, and where we take the floor function of that, and f of B is the maximum difference. So average of B is the taking the average of B, and f of B is the maximum difference between each element of B and average of this B, which we get here. Okay, so this denotes absolute value. Okay, so we are given an array of length and we have to compute the maximum value of f of s across all non-empty subsequences. So a subsequence is basically in an array you can take the sequence, the subsequence. So basically in an array you can, the sequence would be right, but you can delete it and start it afterwards. Okay, the sequence should not change in the subsequent. Let's say basically in the order should not change. Okay, so let's take the first test case. We have got a array, basically 4 8 5 9 1. Okay, so we can see that the optimal subsequence would be 8 9 1. Let's see how for A, right? So average of this would be what? Absolute 8 comma 9 comma 1, right? Okay, which will get to me, we will take over here, which will get me 8 plus 9 plus 1, which is by 3. That is average of B, basically average of A basically, and 18 by 3, which will give me 6. And if I take f of B for that from above, that is 8 comma 9 comma 1. Okay, and where this denotes absolute, so it will be absolute difference of every element of this by its average, basically, or that is 6. Okay, so if we will take an average, so it will be what? Maximum of 6 minus 8 and 6 minus 9, 6 minus 1. Okay, and which will give you maximum of 2 comma 3 comma 5, which will give you 5, right? So that could be the maximum possible. So output is simply 5. So guys, I think the test cases are pretty much clear. Now let's move toward the simple solution. So for a fixed s, it's obvious that the optimal x will be either the minimum or the maximum element of s, whichever is further away from the average, right? So now let's look at the given array A. Given that the minimum and maximum are important for a fixed subset, it makes sense to look at the overall minimum and maximum of A. And indeed, it can be proved that in an optimal choice of S, both minimum of A and maximum of A will be included. So the proof is let m equal to minimum of A. Suppose we choose a subset that doesn't include m. What we will do is discard the existing minimum of the subset and include m instead. Before including m, let of s equal to k and x be its average. So the sum of the set is k times of x, let m2 be the existing minimum of s. Note that the average certainly is greater than m since all elements of the set are greater than m. Let d equal to m2 minus m. Upon replacing m2 with m, the average reduces by d by k. This value is certainly not larger than d. So the decrease in average is offset by the decrease in the minimum of the set, meaning the entire value of average of s minus minimum of s increases. Of course, since the maximum element doesn't change, right? So and also you can see that average decreases, right? So maximum of s minus average of x also increases. This means including minimum of a in the subset is a net profit, right? So similarly, responding reasoning applies to the including maximum of a in our subset, right? So let's use this information to decide what the optimal subset would be like from that sequence. So we want the average of s to be either very far from minimum of a or be very far from maximum of a. So let's try both case separately and take the maximum of both. That will give us the overall optimum. So let's try let's try to maximize average of s minus minimum of a for now. Since minimum of a is fixed, we are really just trying to maximize average of s, and it's thus optimal to choose large elements. However, which large element should we choose? Well, we can just try all possible choices. Observe that if it's optimal to include an element x in the set s, then it's optimal to always include all elements larger than x as well. Suppose x is included and y is not included, where y is greater than equal to x. Let m equal to average of s. Now, if m is lesser than equal to x, then including y into the set will not decrease its average. So it's optimal to include y. So if m is greater than x, then removing x from the set will further increase its average. This goes against x being part of an optimal solution. So it can't happen. So thus, if it's optimal to include x, it's optimal to include y, right? So we can see that this means there are only n minus one possible choices for the set S if we want to maximize average of S. So minimum of A and maximum of A minimum of A and the two largest element of A, minimum of A and the three largest element of A, and minimum of A and the four largest of element of A, such that we can go for minimum of A and the n minus one largest element of A, which is just the entirety of A. So we can simply try all of them and compute the best possible value of average of S. To do this in subquadratic time, we can observe that we can simply sort A, after which we are looking at suffixes of the sorted array. We then want to compute the mean of each set from by taking the first element along with some suffix, which can be done quite easily when the suffix sums of this sorted array are known. This allows us to maximize the value of average of S minus minimum of A. We had to another option, maximizing maximum of A minus average of S. This can be handled similarly, just that we want to minimize average of S instead, so it's optimal to choose element from the prefix of sorted element instead. We can try all options and report the best one, then this take linear times after sorting. So guys, I think the solution is also very clear. Now let's move toward the simple C++ code. So guys, this is my simple C++ code. Yeah, I took the input for all the test cases and I'm calling this solve function over here. So this says I took the input for n and as well as my array. I sorted that array. I initialized sum equal to 0 and answer equal to 0. I'm running a for loop and taking all the sum of that element from that array and taking the mean and answer. I am initializing the maximum of answer comma a of n minus minimum. Okay, mean, basically mean over here, this mean. So sum equal to 0, I'm running a for loop and doing my operations, and at the last I'm simply printing answer. And as you can see that guys, I have got my C++ code right now. Let's move toward the Python code. So guys, this is my Python code. I took the input for all the test cases over here and I call this solve function over here and I initialize n and as well as took my answer as well as I took input from my array. I have sorted my array and I initialize sum prefix equal to 0 and answer equal to 0. I'm running a for loop and doing my summing of the element and also taking the mean, and in the answer I'm storing the maximum of answer comma of n minus mean. And the second loop I'm doing my operation, and the last I'm simply printing my answer. And as you can see that guys, I have got my Python code right. So guys, I think the solution, the code in the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.